All right, so here we go. Perfect square trinomials. That was 3 words. Okay. What is a trinomial? A 3-something, meaning it has 3 terms. 1, 2, 3. 1, 2, 3. What is a perfect square? For example, this is a perfect square. Why? Because it is something squared, right? That right there is a perfect square because it is something squared. Yeah? So a perfect square trinomial is something that when you factor it is going to factor into something squared. Okay, so it kind of combines this idea with the whole factoring thing. Now, do we have to take out what they have in common? Yes, we always have to start with that. So this first part is literally just using snowflake and doing factoring like we did before. We just need to know that every time our answer is going to end up in parentheses squared. So, looking at that first one, what do you think I can take out? I think I can take out a 3.
Why would you say no after she...
What's 7 plus 5?
7 plus 5?
7 plus 5 is 12. That's divisible by 3, so 75 is divisible by 3. What's 1 plus 2 plus 0? 3. That's divisible by 3, so 120 is divisible by 3. What's 4 plus 8? That's divisible by 3, so 48 is divisible by 3. That's your rule for 3s. If you add up the digits and you get something divisible by 3, then the original number is divisible by 3 also. That's just the 3 rule, unfortunately. So that gives me 25x squared. What's 120 divided by 3? 40x. And what's 48 divided by 3? 16. Now, I can snowflake, can't I? So if I were to snowflake this, I would have 25 times 16 on the top, right? That's kind of a pain. What is 25 times 16? 400. And then on the bottom I have, I need 2 numbers that multiply to get 400 and add to get 40. I'll give you a hint. With these perfect square trinomials, these 2 numbers are always going to be the same. Okay? With those perfect square trinomials, those are always going to be the same. What do I put on the top? 25x and 25x. So you are always going to get the same thing on both sides if it's a perfect square trinomial. So what is 25x over 20 reduced to? 5x over 4. This one will also reduce to 5x over 4. So I took out a 3 to begin with. I have 5x plus 4 squared. That's not too bad, right? Okay, let's look at number 2. Can I take anything out? Nope. So let's go to snowflake. I have 16 times 25. Gosh, Franken couldn't have planned this any easier. It's the exact same thing, isn't it? Sort of. Yes, it's 20 and 20, but it's not 25x up top like it was over here. It's 16x. Right? So what is 16x over 20 reduced to? 4x over 5. So it's not 5x plus 4 squared, it's 4x plus 5 squared. Slightly different. Did I seriously do the same thing again? Oh my gosh, Franken, you got to get your act together.
What did you do?
Look at number 3.
Oh.
It's exactly the same as this, isn't it?
I I'm shook.
which means my answer is exactly the same, just without the 3 in front.
You don't have to do it, huh?
So that was a bad example on Franken's part. Shame on
What were
you.
you thinking?
I don't know. Apparently I wasn't. Okay, number 4. What can I take out?
Yeah, 5.
So what does that leave inside? 25n squared minus 10n plus 1.
Oh, shit.
So, what goes on the top? 25 times 1 is 25. On the bottom, negative 10. What are two numbers that multiply to get 25 and add to get negative 10? Negative 5 and negative 5.
Oh, yeah, because you said they're going to be the same.
They're going to be the same every time if it's a perfect square trinomial. I put 25n and 25n. And what does this reduce to? 5n over negative 1.
Dang.
Yeah?
Yeah.
25. So what do I have?
5.
I have a 5 out in front, and then I have 5n minus 1 squared.
Yep.
What part of that answer? Why the what?
Because you took a 5 out.
Because I took a 5 out in the beginning, so that's got to be out in front. And then because this reduces to 5n minus 1, that's why I have the other 5. Okay? Okay. Way better. All right. So let's see. Can I take anything out?
Yeah.
What can I take out? How do you know?
Because the 3 nothing.
So I have 25, oops, sorry, not x, k squared, plus 20k, plus what? 4. All right, you try and factor this one. Is this what you got so far?
Yes.
So I have 3 times 5k plus 2 squared. All right, you do number 6. All right, did you get this one?
No.
Yes, it's easy as.
Yes, I got the answer. And I got it right.
There's no way you can get this off.
Is that what you got?
Yes, oh my gosh.
Woohoo! Okay, now, number 6 is actually the most important one.
Really?
Yes.
Whoa.
Can I explain why?
Yeah.
The reason is because it's the only one that has an A value of 1. When we take this skill and we apply it to problems in a little while, like maybe tomorrow, it's going to be important that we have an A value of 1. So that's going to make your snowflake a lot easier. You're still going to end up with this thing squared, and we're going to use it to solve problems in a different way. Okay? Right now we're just going to practice this though. So, excuse me. Find the value of C that makes a perfect square trinomial? What? And then factor. So do you see where C is? Do you see C?
Yeah.
Right there, 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 and there. So I need to find out what does that number need to be in order to factor into something squared. Do you notice that each one of these problems has an A value of 1?
Yeah.
1, 1, 1, 1. Let's see if we can figure out what C needs to be. Does anyone have any guesses?
Not yet.
I'll give you a hint. There's a 24 right there, so it has to be related to 24 somehow.
Jeez.
Everybody's guessing.
I'll give you another hint. It's going to be bigger than 24. 144. Where did you get that from? Okay, wait. I think you're onto something here. So he said 144, which is correct.
Whoa.
And he said the way he got that was he took the negative 24, in other words, the B value, he divided it by 2, and then what did you do? You squared it.
Interesting.
Very interesting. So what does it factor into then? Plus 12 or minus 12? So in other words, when you take B and you divide it by 2, that answer is what it factors into. Square it, and that tells you what C has to be.
Oh.
What?
So when you divide it, that's what you're factoring.
I'm just gonna drop out.
I don't like it either. Yeah.
I don't
Okay.
understand.
I promise you, once you get these, they make a whole lot of sense and they're super easy. Okay? So if we follow his process, I should be able to take negative 8, divide it by 2. What does that get me? Negative 4. This is going to factor into n minus 4 squared.
Yeah.
And I square this, and that tells me what C has to be.
Yeah.
So before I square it, it gives me what it's going to factor into.
How did you know this?
And if I square it, that tells me what C has to be. Now, do I need to know that negative 4 is what it's going to factor into? No, because once I get my C value, I can take n squared minus 8n plus C, plus 16, right? Just by plugging in the C value I got. And I can snowflake that to get my n minus 4 squared. But if I remember the shortcut, it helps a little bit. Okay?
Yeah.
So let's look at number 9. What is C going to be? I take negative 34. What do I divide it by? 2. What does that give me? Negative 17. So that means it's going to factor into what? Just set it there, it's fine. It's going to factor into what? M minus 17 squared. Save myself the snowflake. And what is C going to have to be? It's going to have to be negative 17 squared. By the way, can C ever be negative for a perfect square trinomial? Because if I square a negative, what happens? It becomes positive. So it's always going to be positive anyways. So C is what? Negative 17 squared, 289. Okay? All right, you try number 10. Tell me what C is and give me the factor. Is that it?
I'm so confused on the bottom.
All right.
Wait, yes, I think
28 divided by 2 is what?
7.
Oh, yes, I'm done.
Oh, shit.
14.
It's something else.
So I have n plus 14 squared. And then when I square the 14, that means that c is equal to what is 14 squared? 196. Okay? So you have a combination of this find the c value thing and this whole perfect square trinomial factoring stuff. Okay? All right. Happy studying.